everyone, and welcome to another episode of Eyes on Earth. Our podcast focuses on our ever-changing planet and on the people at Eros and across the globe who use remote sensing to monitor the health of Earth. My name is Jane Lawson, and I'll be your host for this episode. Today, we're talking about a new publication with satellite images that reveal dramatic changes in non-ocean surface water over time. Typically, researchers peer at satellite images on a computer screen, but then it's easy to miss the beauty revealed in some of the most striking ones. So Dr. Belward felt inspired to translate his work of mapping 3 decades of change in global surface water into a printed book. The original mapping product of his work, called the Global Surface Water Explorer, was made with 3 million Landsat satellite images. That's available online, and so is a PDF version of the book Atlas of Global Surface Water Dynamics. But a computer screen can't show the full impact of maps and photos like a book with pages that are open nearly 2 feet wide. Dr. Belward joins us today to talk about this collaborative book and how it showcases satellite technology. He works in Italy as a scientist in the European Union's Joint Research Center. He's currently focused on agricultural policy. He spent about 10 years on the USGS NASA Landsat Science Team. Before he became involved in a global study of surface water, he had also worked on a global study of forests. Both used Landsat images to show change over time. Dr. Belward, welcome to Eyes on Earth.
Hello, thank you.
First of all, when we're talking about surface water on Earth, what types of water bodies does that all include, and what are some ways they might change over time? Losing or gaining water?
At its most basic, it's all water. So it's all the lakes, it's all the rivers, it's all the wetlands. But it could even be things like the reflecting pool in the National Mall. We see that too. So it's not just natural water bodies, it's all surface water. So anything from the Great Lakes to the reflecting pool, if you like. All of these things change over time. That's the important thing. Rivers meander and move. Some of them change direction entirely. If you put a dam across the river flow changes, but you create a lake behind the dam. So what was once land becomes water. If a lake drains, what was water becomes land. In the case of wetlands, it could be within a single year. Perhaps the water body, the lake or the river, only flows for a few months of the year, and it might not even be every year. It's not just climate, it's the way people are using the water as well that's affecting the patterns that we see around the planet.
How did satellites, especially Landsat, help you measure that change, and why is it important to study those changes?
Change can happen anywhere, anytime. You can create a dam pretty much on any river and turn it into a lake if you like. And lakes can disappear anywhere around the world. So you have to look at the entire Earth's surface. Doing that in an aeroplane or on the ground is just impossible. You just can't do it. From a satellite, you can. And the Landsat program has 2 absolutely crucial factors for us. One is that the spatial detail, we're mapping rivers and lakes and wetlands that are bigger than 30 by 30 meters everywhere on the surface. The wavelengths that the satellite measures is right because it allows us to discriminate between clouds and the land surface and snow and the land surface and ice and the land surface. So we're able to detect water very well. And then the third thing is that we can measure this change over a 35-year period. It's important to study the changes in water because fundamentally, no water, no life. I mean, we need it for every aspect of our daily lives. When was the last time you went more than a few hours without using water? If you went more than a few hours, you really noticed it. If you went a few days, you're in deep, deep trouble. So it affects every element of your life, but it also affects not just your life, but all life. So biodiversity, landscapes, agriculture, manufacturing, commerce, transport, energy production. We need it for generating electricity, not just hydroelectricity, but thermal electricity with the steam that drives the turbines. And the climate system, it's absolutely a fundamental part of the climate system. The very big lakes affect the way in which the energy and the gas exchange and even the surface roughness of the planet appears. So it affects our climate and our weather too. It couldn't be more important.
How did the idea of creating a book out of satellite images come about? And then how did it evolve over time as you were working on it?
We started out by wanting to actually make the measurements of where is the water, when was the water, how has it changed. So all that was computer-based. I think what happened was that as we spent more time looking at the images, we realized that there was a real beauty to it. It was a science and an art coming together. The Landsat scale is so detailed that when you look at it on the screen, you're just looking at a very small area. We first printed out just a few sheets and thought, gosh, these are very beautiful. And then thought maybe it would be a good idea to put it together in a book. Of course, you then have to decide on what else do you put in the book. You have to explain how the satellite works, how remote sensing works, how you actually created the maps, why you map. It evolved from a sort of an art project to a science project very quickly.
So you're sort of educating with the book in addition to showing these beautiful pictures.
Yeah, I think that's true. Yeah, in the end, we wanted to include the whole stories. Even the very early days of when the very first pictures from space were taken and the actual film canister was parachuted back to Earth and then caught in the air, and those sort of things, just to let the reader know where these images come from, that this is a science that's been going on for a long time. But that heritage is what gives us the power to produce these maps with time in them. And we even had to explain what we mean by putting time into maps, so that when you look at the map, you're not just looking at a map of where there's water, it's when there's water and how long there's been water. And if there was water, what is it now? You know, it's gone from water to land. So all those changes. It did involve quite a lot of science in the end as well. And then we had to make sure that that science was accessible.
What are some of the most striking images, and you have stories with them? What are the most striking ones that you included in the book?
When we started it, we thought, oh, the planet's getting warmer, and so there's probably a lot less water around because all the lakes are drying up. And then we discovered that actually that wasn't the case. And over about 30 years, we've lost something like 90,000 square kilometers of water, but we've gained about 180,000 square kilometers. Much of that is because of dam building. We build a lot of dams around the world, but also some of it is because of a changing climate. So you've got stories like Lake Mead.
Oh, sure. Lake Mead on the Colorado River. That supplies water to Las Vegas, right? Why does that stand out?
Not just because of the changes in the dam and the area of the lake. You also see Las Vegas and how Las Vegas has expanded. It's not just cause and effect, but you realize the risk involved in losing surface water. There's a dam called Tewaterskloof Dam outside Cape Town, which has had the same sort of changes as Lake Mead. But in the case of the Cape Town Dam, it got extremely dangerous in 2018. And I think it was the 12th of April 2018, they had as 0 day when the city was scheduled to run out of water. And you see those changes in the satellite images and in the maps. And that's pretty compelling. Then you get pictures of just sheer beauty like the Brahmaputra River and the way that the braided channels move over time. Very sad stories like the Paksong Dam in Laos that collapsed in 2018 and resulted in a number of deaths. So it's a mixture of compelling science, compelling human stories, big picture science as well. All the dams on the high elevation plateau, the Tibet Plateau, all of those lakes are expanding.
Who do you most want to read this publication, and what effect would you like it to have?
I would like it to be scientists. I'd like it to be politicians, people who make decisions on how we manage surface water, on are we going to build that dam or are we going to remove that dam? But I think also the general public, school kids, they should read it. University students might find some of it useful. The initial audience was definitely the sort of the politician, the people making decisions, the environmentalists. It provides some sense that the science has an impact on your daily life. The effect we would like to have is that people realize just how precious that water is and don't abuse the water. Think about it when you're using it. Think about when you're eating your food, how much that's used water to get there. So just to perhaps take more notice of this absolutely critical part of your daily life.
So you've looked at satellite images for a long time. How is seeing them when you open the book different than when you scroll through them on a screen?
Another good question. It was almost emotional, actually, because it did bring forward just how beautiful our world is. Beautiful and fragile and changing. When it's a book, you get the whole end-to-end story. So you're able to see in one place not just why surface water is important and where it is and why you would map it and how you would map it, and then you see the maps as well. That is not possible to get in the same way on a screen. It's somehow easier to keep track of the characters.
Well, you've been doing your research for a few decades now. What improvements in satellite technology have made a difference to you, and how important are they in helping the people on our planet now and in the future?
The obvious one that everybody thinks about is the spatial detail. You know, the fact that you used to be able to just look at a football field and now you can see practically a player on a tennis field. You can see the two players at either end. But that's not actually the biggest change for me and for our work. It's not spatial resolution so much. The biggest change has been the availability of the data, I think. It's the fact that those data suddenly were made available, and they were made available to everybody. And it was the Landsat program that actually led the way on that. And then the Copernicus program in Europe has followed suit. Then there's the actual quality of the measurements. And there's no doubt that Landsat 8 and Sentinel-2 that we're using today make finer quality measurements. The radiometry is better. So you actually get a finer measurement on the land surface. And I think that that's been a very important factor as well. I think the way in terms of helping the people on our planet, when I first started getting involved in this stuff, you saw Landsat and you had this notion of a satellite that was taking pictures of the Earth's surface every 16 days. But the reality of being able to harness that in time was open to very, very few people. And now it's open to everybody. And we're able to build up these pictures of change, whether it's water or agriculture or forests or cities, the spread of cities. We're getting much more data rich. And that helps because it's an old adage, but you can't manage what you don't measure, and the satellite doesn't help us measure.
Do you have any closing thoughts today?
Don't take the satellite images and the satellite programs for granted. It's an odd thing, but we've got so used to seeing satellite pictures now on the web, on the news, on the television. They illustrate stories. They're in the newspapers. They're in the magazines and the journals you read. They're pretty ubiquitous. But the science and the engineering that underpins those programs like Landsat and Copernicus, are profound. And you need highly skilled people to build those sensors and to build those satellites and launch them. So there's a profound scientific and engineering skill that underpins it. The value of the information that you can also get out from those programs is profound as well. Don't take them for granted, and let's hope that those programs are around for a long time to come.
Well, thank you so much, Dr. Belward, for joining us for this episode of Eyes on Earth, and thank you to the listeners, too. Check out our AROS Facebook and Twitter pages to watch for our newest episodes, and you can also subscribe to us on Apple Podcasts. This podcast is a product of the U.S. Geological Survey, Department of the Interior.